All right, today we are going to talk about alpha. Alpha is a very key and important idea from statistics, and we're going to talk about it in terms of a really cool psychic experiment that we're going to do over YouTube. So let's get started. In stats, alpha, which is the first letter of the Greek alphabet written in lowercase, alpha is the threshold of statistical significance, and I want you to understand what that means. It's all about how willing you are to believe that something must be up, how willing you are to say, oh, it cannot be a coincidence. So in order to understand what is really going on with alpha, we're going to do a really cool psychic experiment through the computer. All right, here's our psychic experiment. We are going to perform a coin flip, and you are going to be the psychic, and you are going to predict the outcome of the coin toss. Okay, here we go. So I'm going to flip the coin, and before I do, you are going to choose your side. Heads or tails? I'll give you a minute to choose. Okay, hopefully you're going to stick to your choice. Now, here I go. I'm going to flip the coin and it scores. Oh, okay, it's tails. Here, I'll show you. Yeah, see, it's tails. Okay, now some of you are impressed and some of you are not impressed. And that's kind of natural, right? So this is not a very impressive trick. And the reason this is not a very impressive trick is that even if you were right, the probability was 50-50 that you would be right. And so it's just really not very impressive. What are the chances of coincidentally being right? That is, if you had no psychic powers, what are the chances of being right? So chances of coincidentally being right is 50-50. So coincidentally correct 50% of the time. And I think we all have an understanding here that if your chances of being coincidentally right are 50% of the time, and you just happen to be right, then you probably just happen to be right. It's not some psychic thing going on. So let's do a better example. We got some cards here. Whoa, I can't even hold on to them, okay? I'm such a talented dealer. Okay, so we got some cards here. I'm gonna shuffle them up, shuffle them up, shuffle them up. And while I'm shuffling up these cards and trying not to show them to the camera here, I'm shuffling up these. I'm even dropping some on the floor. I've got no talent at all here. So I'm shuffling up these cards, and now I want you to think of a card in your mind. Okay, so there's this magical psychic trick. I want you to think of a card. Okay, thinking of a card. I'm thinking of a card. Okay, now I'm gonna. Now you can't see them. Hopefully you can't see them reflected in my glasses or anything crazy like that. So I'm gonna pick a card. You think of a card in your mind, and I'm gonna give you a minute to think. Okay. So think, 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 make your choice. Put it on pause if you need a few more minutes to decide your card. And then here we go. The big reveal. The card is dun dun dun. Two of clubs. Was that your card? Now, right now, lots of people all over the internet are saying, this guy doesn't know what he's doing. But there's that one poor sap on the other end of this video thinking, oh my God, how did he do it? Well, it was a coincidence. Okay, so I got it right maybe 1 out of 50 times. And because more than 58 people have to watch my videos, well, you know, one of you is probably a little bit freaked out, but I promise it's just a coincidence. So the question here is, how willing are you to believe that it couldn't be a coincidence, right? So how willing? So the chances of being coincidentally right here, they are about 1 in 52, maybe fewer because I dropped some cards while I was shuffling. But we'll say about 1 in 52 because that's how many cards there actually are. And that's about 2%. So if I was right, you're more impressed, right? If I was right, you're more willing to say, it couldn't just be a coincidence. There must be something going on. What's going on? I don't know. All right, let's move on to our next example. Pick a number from 1 to a million. Okay. Pick a number from 1 to a million. I'm going to guess your number. Okay. Is your number 451,799? Oh, maybe it isn't, but maybe it is. And if it is, you're pretty impressed, right? So the chances here of being coincidentally correct those chances are, of course, 1 in a million, which is really tiny. And that means that if I was right, if I just happened to be right, then you would say, wow, like something is going on here. So all of us have this threshold where we're willing to say, that was probably just a coincidence. That probably doesn't mean anything. My cousin wants something, but it probably doesn't mean anything, right? I heard about a guy, but it was probably a coincidence, right? So we all have these thresholds where we say, oh, that was probably just a coincidence, right? It doesn't really matter. It doesn't really mean anything. But then eventually, if something really striking happens, if something really shocking, especially if it happens directly to us, then we'll say, that can't be a coincidence. There must be something going on. So if I perform this card trick in person, then you might think, okay, that's not going to be a coincidence. Maybe it's not psychic powers, maybe it's sleight of hand, but there's something going on, right? But even if I perform this coin trick in person and you get it right, you're not likely to say, oh, it couldn't be a coincidence because it's 50-50. Of course it could be a coincidence, right? That's easy, right? We all have these thresholds about how willing we are to tolerate coincidence and how ready we are to say there must be something there. And that threshold, that's what alpha is. See, alpha gives us a number to that credibility of your personality that allows you to say, okay, I believe in it something. Like something now, something's going on here. This is not a coincidence. So alpha is sort of how believable you are, how gullible you are, or how willing to believe that it can't be a coincidence you are. And I want to talk about the personalities, the various, let's talk about the personality types, right? There are the introverts and the extroverts, these alphas, those alphas. So I want to talk about the various kinds of ways of thinking so that you get a sense for what this number alpha really means. This number alpha measures how ready to believe you are. And it's a number between 0 and 1. And so we're just going to talk about some of the values that it could take and what they mean about you. And you can find yourself in this list somewhere. So let's erase our silly psychic experiment. And let's talk about what alpha means. So the most interesting value of alpha, maybe the least interesting value of alpha, is alpha equals 1. It doesn't get any better than that, okay? Alpha equals 1. It sounds really good, right? But actually, it's really bad. Alpha equals 1 means I will believe anything you tell me, right? This is not a very good way of going about life. So somebody tells me, oh, you know that hat you had yesterday? Oh, yeah, it was not a hat. It was a cobra. And then I'll, oh, okay, without any evidence, right? It doesn't matter. Oh, actually, Donald Trump is not president. Okay, whatever you say, okay, right? I'll believe anything, right? So alpha equals 1 means I'll believe anything. It doesn't matter what evidence you have, and it doesn't matter how far-fetched it is, and it doesn't matter what's the probability of it being true in a, what's the probability of it being just a coincidence. I will believe absolutely anything you tell me. Alpha equals 0.5 is also dangerously credible. So you can think of this as 50%, right? Basically, I will believe things very easily. So very, very easily. All you need is a little bit of evidence. So basically, alpha equals 0.5 is the kind of person who believes I'm psychic because they guessed this right? All they need is to say, what are the chances of a coincidence? Only 1 in 2. It can't be a coincidence, right? Then they'll say, oh, there must be something going on here, right? Basically, alpha equals 0.5 means you're not willing to believe that it was just a coincidence if the chance of that coincidence was 1 in 2 because it's so far-fetched, okay? Clearly, this is like way too credible. Alpha equals 0.5 is like dangerously credible. You're willing to believe anything. Basically, a little bit of anecdotal evidence for something, and you will just believe it, right? So that's really dangerously credible. Let's go kind of to the other extreme. Alpha equals 0. This is the lowest alpha you could possibly have. Now, I suppose among statisticians, we could probably have an interesting argument about whether alpha equals 0 people believe nothing at all or believe slightly differently. So, my interpretation of what alpha equals 0 should mean is that you should be like 0 credibility. I mean, sorry, 0 believability, but you should probably still be persuaded by absolute proof. So only absolute mathematical proof will convince you of anything. if there is any possibility of anything ever being explained by a coincidence, then you will not believe it. Now, this might sound like the most responsible way to organize your brain so that, oh, I'm just sort of perfect. And honestly, like as a mathematician, I sort of feel like there's some appeal to this. But honestly, this is not a very good way to go about living your life because you basically will end up agnostic about everything that matters, right? Like, supposing you really enjoy eating ham sandwiches, you will never actually believe that you enjoy eating ham sandwiches because you will always think that maybe I was just in a good mood every day I ever tasted a ham sandwich, right? You won't actually ever believe anything about the world. You won't believe that electrons are real, and you won't believe in the theory of gravity, and you won't believe in the theory of evolution, and you won't believe really anything about the world because everything that's measured about the world could have been just an accident of the numbers as they fell out that day. So alpha equals 0 is too strict. Now, science has to operate, right? So science has to operate on evidence, and evidence could be interpreted as some kind of numerical coincidence. So believing everything you hear is a really bad idea from the point of view of science. And believing nothing is actually an equally bad idea from a point of view of science. Actually, in order to do science responsibly, we have to be able to say at some point, no, I don't believe this could be a coincidence, even though it's not mathematically certainly given, right? Let's talk about alpha equals 0.05. This is a very important standard value. And this means that you are a typical scientist. And let's talk about what that means. So a typical scientist about standards of proof. It's not really fair, by the way, for me to say typical scientist, because the different sciences have different levels of standards of proof. Like the social sciences kind of have a different level from the physics. Like if you talk to the particle physicists, they're never going to be at this level, but let's not sweat that. So what does this mean to be an alpha equals 0.05 person? If you are an alpha equals 0.05 person, then you're pretty skeptical and you don't believe things very easily. But when presented with some pretty good evidence, you like to say, could that be a coincidence? And if the answer to that question is, well, yeah, it could, but only with like a 4% probability would it happen by coincidence, then you'll be like, yeah, that's convincing. That's persuasive, right? So this is the kind of person who, when they win this card game, right? Pick a card, okay? And then it just happens that that's your card. Wow. This is the kind of person who says, there was only a 2% chance that that would happen by coincidence. And so I don't think that was a coincidence. I think that was something special. Maybe it was sleight of hand, maybe it was psychic, maybe it was like whatever. I don't know. Maybe it was something other than coincidence, right? This is the kind of person who rejects an explanation that it was just coincidence because the coincidence probability was only 2%. So basically 0.05 is 1 in 20. So the fraction 1 divided by 20 is 0.05. This is somebody who says, if the chances that a coincidence could make that are less than 1 in 20, then I don't really think a coincidence would make that. I think we actually are looking at something here. And that's a kind of a pretty responsible but flexible point of view for scientists generally. And so this is a pretty standard way of sort of calibrating our believability in science. What do we do with this? Well, we'll get to that later, right? We're going to compare our p-values to this, but we haven't introduced p-values yet. I'm starting with alpha and we'll get to p-values later. There are other values that are appropriate in science. Some scientists will say, oh, alpha equals 0.01 is better. Basically, I will believe it if a coincidence couldn't produce it. So if only a very rare coincidence. And how rare? We can say how rare because 0.01 is 1/100th. So a 1 in 100 probability. If only a very rare coincidence could do that. So basically, if your alpha is 0.01, then you're the kind of person that says, what are the chances that a coincidence could really do that? And then if you're lucky enough to be able to work that out and know what are the chances that a coincidence, if you're lucky enough, you can calculate it, right? then it's like, oh, well, it would only happen like 1 in 100 times if it were going to be a coincidence. Then you're like, I don't think it is a coincidence. I think there's really something going on. That's this level of skepticism here. The lower the alpha, the more skeptical you are, right? There's a movement afoot to say, oh, you know what? Let's all get on board. Alpha should really be 0.05, right? There's a movement afoot to say we should all be using this value of alpha. That's 1 in 200 coincidence, and as opposed to this, which is 1 in 20. This is more skeptical, but it's also harder to prove anything to somebody who's more skeptical. And so, it makes it harder to prove things. So this is a new proposed standard for how skeptical science generally should be. So the cool thing about alpha is we can actually say on a numerical level how skeptical we should be, how skeptical science should be, how skeptical everybody should be as a rule. These are impractical levels, right? This believe anything, believe almost anything, believe essentially nothing except that which can be mathematically proven. But this alpha equals 0.05 is a pretty decent global standard for how skeptical we can all be in science. And as long as we agree to some level of appropriate skepticism in scientific result, then we can communicate those results in a way that we all understand. And so here, what's the real miracle of this is not that we've learned how skeptical to be, but we've learned how to describe how skeptical we are and how to describe our results in terms of that. And that's really beneficial here. So in most problems that we'll do in this course, we will assume by default that the alpha, which is really the measurement of skepticism or how readily we are to believe things, how readily we believe things, that we will assume for most purposes in this course that it's 0.05. That's going to be our standard default, and that's pretty typical in statistics because it's pretty typical in the sciences generally, especially the social sciences, to just have that level, and that's our alpha. That's how credible we are. That's how willing we are to believe things. It's a standard of proof, which is like a responsible level of proof, but it's not so incredibly rigorous that like almost all results will fail. If we make alpha lower and lower and lower, then we risk not being able to prove things and not being able to really come up with the scientific knowledge that we need. If we make it too high, then we risk just being too credulous. We just believe anything anybody tells us, and that's not good either. So that's what alpha is all about. And when we run our hypothesis tests, I want you to watch for this alpha. We're going to, but in order to use it, we're going to need to answer this question. What are the chances that that would happen? What are the chances that that's coincidental, right? For a pack of cards where there are roughly 50 of them, 52, then it's easy to say the chance that it would have been that one in particular is 1 in 52. And for a coin, where there are two options, it's pretty clear the chance that that would happen was going to be 1 in 2. But if you're measuring some weird survey and you're asking what are the chances that the managers would look this biased on that survey, then it's much, much more difficult to measure what are the chances that it would have been that way if it were just a coincidence. But we will learn to measure it. And when we learn to measure it, then we'll be able to compare it to some standard level of believability. And so that's what alpha is all about.